God, she's the nicest person and you're the laziest.
You're gonna start the tape off like that?
I already did. Hi, Nurse Tiffany. Your son is a real pill. He's naughty. No one likes him. And especially nowadays, the data that they're using is bad data, right? Well, and here's what. When we used to have the SAT as target, and when we used to not looking for a wide range of students, I'm seeing people getting to Cal who historically haven't, right? It's a brand new world, so that data is old. Don't use that data, right? Yeah, don't. Okay, here we go. You know who there's only one, to be honest, there's only one group that should look at that data. White, middle class, and upper class white folks. I mean that honestly, because they're overrepresented, right? So, everyone else, that data doesn't apply to. For Thomas, that data is for you, right? Okay, here we go, rock and rollers. Liam, you ready? Okay, so we're talking about intercepts today. It is another way that we can do graphing. And by the end of this period, you might feel like, hey, you know what? I'm actually okay with this. My math skills are good enough now that I can do this. Now, I am going to tell you, I personally, Dana Tarantino, has a little bit of sticking point with intercepts, and I'm going to tell you why in a hot minute. So we're going to talk about what a y-intercept and an x-intercept is. We're used to a y-intercept. I have a little dot there because often we think of this as the easy one, right? This is sometimes the easier one. I literally have some software that will literally label the intercepts as the easy side and the hard side. So it's pretty crazy. But here's what an intercept is. The y-intercept is this. You might want to write this definition down. Where a graph touches the y-axis. Now, here's what. Today, I'm going to ask you to not just give it to me as a number. I'm going to ask you to give this intercept to me as an ordered pair. And here's where I mess up. So I'm going to tell you this goofy story. So my mom is no longer with me, but I love my mom to death. But my mom had a tendency to, like, whatever word stuck in her head, like she would remember it even if it was incorrect. I'll give you an example. I hate tomatoes, raw tomatoes, on anything. And I would say, my mom would say, I'm making you a sandwich, do you want tomatoes? And I'd be like, no, I don't like tomatoes on my sandwich. And here's what my mom would do. She would think to herself, Dana, tomatoes. And every sandwich she would make for me would have tomatoes on them. And I'd be like, no, I don't like them. It's like, okay, I'm going to remember that. Dana, tomatoes. It's like, no, you're forgetting the not word, right? So here's what we have a tendency to do. When we're doing these, we're going to make an ordered pair. And when we're looking for the y-intercept, something is going to be 0, right? But we have a tendency here, let me move this back there and you can't see. We have a tendency, at least I do, to think to myself, oh, y-intercept, that means y is 0. And that's not it. So here's what I want you guys to do when we're doing these. When I'm talking about an x-intercept or a y-intercept, I want you to think y line. That's what you're solving for. You want that number. This guy is the 0. Does that make sense? But if you're like me, I have a tendency, like literally when I come around to help you, you'll be like, which one is the x? And I'm like, I have to think about it, right? So what is the x-intercept? Well, that is obviously where a graph, and it can be any kind of graph, touches the x-axis But here's what, when we write it as an ordered pair, here's what I want you to remember. X-axis, that's what we're looking for. We're looking for that dude. The 0 is going to go there. Does that make sense? There is another piece, though, that I need you to write down on x-intercept. It actually has a second important part that we're going to talk about in a little bit in this class. It is also referred to as a 0. And we're going to talk about what that means in about 10 minutes, right? So here's what's handy about this. It turns out that we can do some really nice graphing by doing this because we love plugging in 0. It's our total friend. So here's what we're going to do. We're going to do like 4 graphs, and we're going to try doing them with intercepts. And you're going to be like, hey, that's not a bad way to do it. And you're like, oh, but Miss C, you didn't give us graph paper. And you're right. When you're graphing with intercepts, you don't actually need graph paper. And I'm going to show you why that is. So here we go. We're going to start with this bad boy. And what we need to know is we need to know the 2 intercepts. We need to know the x-intercept, and that's where it's going to touch this guy, and I'm going to make it in red. And we're going to need to know the y-intercept, and I'm going to put it right here in blue, right? So here's how I do it. I go up here, and right away, I know I'm going to be looking for x, so that is y. I am going to now go to my equation, and everywhere I see a y, what am I putting instead? 0. And watch what happens. 0 times anything is what? It's 0. It goes away. Oh my God, we love that. So 2x equals 6. So what does x equal? 3. So easy. Now I just literally go to my x line, and I go to 3. 1, 2, 3, I put a dot. Easy as that. Now I'm going to do the y-intercept, and I'm going to do it the exact same way. But this time, I'm going to say to myself, I'm looking for y. That's my 0. Everywhere I see a 0 for x, or x, I put a 0. That just wipes this guy out. I'm going to get negative 3y equals 6, or y equals negative 2. Look at this. 1, 2. I'm done. I'm done. That's it. I'll be honest. I think that's faster than solving for y. We all have a tendency to solve for y because it's what we've done so many years, right? But I'm not going to lie. After teaching this lesson 3 times, I feel like maybe I have a newfound love of intercept because it's not so bad, right? You guys ready to try one? Here we go, rock and rollers. I would like you to do 2 things for me. I would like you to write the x-intercept down and the y-intercept down, and I'd like you to graph it. This is hardly ever absent. I start by doing this. I'm going to throw that 0 in. Nice and easy. Oh, look at that. 9. So easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. Not even tricky. I'm going to come back and do it again. I'm going to put a 0 in. I'm looking for y. Put my 0 in here. I get negative 3. 1, 2, 3. Done. How'd you do? You okay? Easy, yeah? Like that would have taken a lot of work to do it the other way. And who knew? That was pretty easy to do. Yeah? We're going to do 2 more. The next one is a trick. I'm just going to say it right off the top. It's a trick. And we're going to talk about it. but we're going to find another way to do it besides intercepts. Yeah, look at this bad boy. Before we dive into this, before we just start, because I do want to know the intercepts, right? I want to know the intercepts. This is my x-intercept, and this is my y-intercept. But before we dive into this, we're going to graph this one first. It's because it's a heartbreak problem, right? That it's missing a letter. So most of you, it's like, oh, wait, Misty, that's one of those weird heartbreak ones. So it says go to y, go to 3, put a heart there, breaks a heart, right? So that bad boy's done. That's done. The graphing is done. But let's now look at the x and y intercept. Where does that bad boy hit the x line? Nowhere. It never will. It's horizontal, right? So our answer to this one is, what is the x-intercept? Yeah, none. There is none. There is none. And what is the y-intercept? Guess what? It's 3 everywhere. It's 3. It's 3. It's 3. It's 3. It's 3. Right? Does that make sense? So just keep an eye out for those ones. If they're the weird heartbreak problems, that they may not have an intercept, right? So just keep an eye out. They sneak up on us, but you got this. Okay, last one of these, and then we got one other thing, and then we're done for today. I'm rolling. Ooh, scary, bad, frightening, but not really, right? Not really, because when we use intercepts, it gets rid of a bunch of stuff, right? So we don't freak out about the fraction. So let's take a look at this one and do it together. So my x-intercept, remember, it's going to be blank, comma, 0. My y-intercept is going to be 0, comma, blank. Here we go. You ready? So I'm going to start here. Caesar, are you with me? Yeah. I'm going to go ahead and I'm going to plug in 0 for y. It wipes out all of that stuff. So here's what's left. 2 over 5x equals 1/2. How do I get rid of a fraction when it's next to an x like that? What do I do to it? Do I move it to the other side? You remember, I know you do. Multiply by that. There you go, reciprocal, there you go. I'm going to flip it over, flip and kick. I flip this guy over and kick him to the other side, right? Multiply by the reciprocal. Oh my God, I felt like Ferris Bueller's teacher there. Anyone? Higher, lower? Oh my God. So here's what I get, just times straight across. 5 over 4. And you're like, but Miss Tarantino, that's a scary number. That's why we like intercepts. Because guess what I'm going to do? I'm just going to go right here and be like, 5 over 4. Good enough, right? So with that in mind, can you please find the y-intercept for me? Now that you know how to do it and you're not scared of it. I'm telling you, it's a whole lot less work than multiplying through and moving everything. Yeah, do we get kind of funky answers? Sure, that happens sometimes. Let's preach out. We can handle that. I can almost do this one in my head. There you can. Did you get 3 over 4? Yeah? So guess what I'm going to do? I'm going to put them right here. 3 over 4. And I'm going to draw it in. And you know what? Good enough. That's a damn good approximation. We're good. Yeah? Intercepts. Who knew? Right? Who knew that they could be okay? So that's a cool way. So here's what I want to do. Before we move on onto a whiteboard desk, it's going to give me an opportunity to check where we're at. We're going to roll back to our little starter, this dude right here. Can you please do this problem now using intercepts? Using intercepts. You'll find out it's pretty easy. Don't forget to get rid of something over 3. We times both sides by 3. And you're like, wait, this is a whole lot easier than doing all that crazy moving stuff. We're up here not speaking this. Anyone confident? Someone got something? Anyone brave enough to tell me what they got for their x-intercept? Where does this bad boy hit x? Anyone brave enough to tell me? What do you think? Absolutely. Right on. You know what I did? I got rid of this guy. Times both sides by 3. Man, that's so easy. I'm running out of space, so I'm going to put it right here. And the other guy, anyone brave enough to tell me what they got for the other guy? Nice and easy. -2. Right on, right on. -2. Boom. Right here. There's my same line. And when we did it, we went here, and then look, it's still that same line. So I got to be honest. I think it would almost be faster to do that guy by intercepts, right? Not a tool in our tool belt. Often, I think on the test, I might ask you to do it, like find the intercepts on one problem, but I just want you to have more tools to be able to be fast at this. Okay, last thing I got to tell you, last little bit of notes, and then I am shutting up for the day. Yay me, my day is over. Did you need me? Oh, you didn't. Last thing is this. So here's what. Have you ever noticed that sometimes the more we go in math, the more we like ask for things, like it means the same thing, but we say it in different ways, right? Like we have it this way, or we can have it this way, right? We can write it like this. We could also write it like this, x/3, right? Like you're starting to realize as we become more sophisticated, it's like, yeah, you're asking for things in all the same way, right? So here's what I need you to know, that when someone asks for a 0, when they're asking for a 0, what that really means is they're asking for the x-intercept. So I don't know if you remember. I'm going to show you something. You can even put your pencils down. You don't even have to do this. I'm going to show you a problem from last year, and it's going to make your like chest compress a little bit because you're going to think, oh my God, I hated those. And welcome to pre-calc. So we did a problem that looked like this. We said x squared minus 2x minus 24 equals 0, right? And we solved this baby. And here's what we did. And you're like, duh. We did a little x factoring. Factors of 24 that make -2. Anyone brave enough to think in their little thinky brains? 2 numbers that multiply to be 24, but when you subtract them, make -2. Right on, -6 and 4. I heard that. That was awesome. So good. So here's what we got. We got x minus 6, x plus 4, and then we solved it. We're solving for x. We're figuring out what x is when it equals 0. So what we got was 6 and -4. Now I'm going to show you when you graph this baby, the graph looked like this. That was 6. This was -4. The graph looked like this. So sometimes I said solve for x. Sometimes I said find the roots. And another way I could say all of this is find the zeros. Because what it's asking for is where does this bad boy hit the x line? And when you're doing it, all you do is set it equal to 0. So when you see a problem like this, and it looks super scary tonight, and it says find the zeros of this, here's what you do, and you're going to be like, oh, Miss T, that's so easy. What you're saying is, what is x when this y is 0? That is all it's asking. It's asking you to solve for x when y is 0, right? Or f of x is 0. Move that 5 over. I get 1/3 x times both sides by 3. I'm going to get x equals 15, right? It doesn't mean you plug in 0. It means you're setting it equal to 0. You're finding x. Is everybody cool with that? A little bit of trickiness. Just want to make sure we're okay. Look, I'm actually going to turn this off on time. I've been letting it run. Poor people at home. Bye, COVID kids. Feel better.